Welcome back, everybody. Today we're going to continue still thinking about ratios and rates, but take it a little bit further and talk about something called proportions. So that's going to be my title for today. And again, we have a little definition here. A proportion is a statement that two ratios or rates, again, rates are the same thing, but they're just different units, are equal. So for instance, you have something like A over B is equal to C over D, right? So you have one fraction is equal to another fraction. That's all it is. That's a proportion. It says that two ratios are actually equal. So for example, three sixths equals 1/2. This is a true statement. This is a proportion. These two ratios or rates, I don't even give it a meaning here, but they're the same, right? 3/6 and 1/2. If you were to simplify 3/6, I think you can all do that at home, you would get 1/2. So you can see that these two ratios are the same. This is a proportion. Okay. So you have the idea of ratio equals ratio. And of course it's true, right? So we're not just setting anything equal to each other. It actually has to be a true statement as well. And you can also do it with rates. So we can also read this three is to six as one is to two. So I know in math, I'm used to saying something like 3/6 equals 1/2, which is perfectly fine. But if you want to read it as ratios, we could say 3 is to 6 as 1 is to 2. So here's your first ratio of 3/6. And here's your second ratio of 1/2. So I kind of feel like I'm in an English class here, reading those statements. All right, so let's do some examples. Write each sentence as a proportion. So let's do one example here. 12 diamonds is to 15 rubies as 4 diamonds is to 5 rubies. So we have 12 diamonds compared to 15 rubies. So that's our first ratio, equals 4 diamonds compared to 5 rubies. Notice that if I look at just the numbers, if I were to simplify these each by 3, so dividing by 3 over 3 here, you do get 4/5. So the numbers are the same. They are actually equal. We have equivalent fractions here. And then also know that the units match. So you do have to have this idea that everything is consistent in a proportion. So here, if I'm doing diamonds to rubies on the left, I need the same order of diamonds to rubies on the right. That is really important. You can't mix it up and do like diamonds to rubies and then rubies to diamonds. They have to be the same. So another way to write this without the units, you could write it as 12 to 15 is to 4 to 5. And then just kind of keep in mind that these top numbers represent diamonds and these bottom numbers represent rubies. So again, there's some consistency there as we set up our proportions. Now let's go to the next page. Okay, a sports example here. 5 hits is to 9 at-bats, as 20 hits is to 36 at-bats. Okay, so here is our first ratio. So I have 5 hits comparing to 9 at-bats. And then my second ratio is 20 hits to 36 at-bats. And again, you can actually check that these are equivalent, right? So notice that 9 times 4 is 36, and 5 times 4 is 20. So multiplying by 4 in both the numerator and denominator will give me that equivalent fraction. So it does work out here. Okay, and again, if you prefer to just kind of have your numbers in there, you can do that. I do recommend, though, that you write the units somewhere. So, you could also do it like this: hits to at-bats, and just write that off to the side so that you stay consistent, which is really important here. So again, we're doing hits to hits, at-bats to at-bats. So I have been kind of checking here that my numbers actually make sense as we go along, right? So how do you actually check that a proportion is true, that it has been set up particularly correctly here? So one way is you could either simplify fractions to get equivalent fractions, or see if we can multiply to get equivalent fractions. Oops, multiply to get equivalent fractions. And we did this actually in the first 2 examples. So in our first example, we had 12 over 15. And if we divided those each by 3, so we're simplifying here, we got 4/5, which was our first example on the page before. And then in this example, we took 5/9, and we were able to notice that if we multiplied these both by 4, we were able to get those equivalent fractions that of 20 over 36. So one way to check is just to use your standard tools for working with fractions. You can multiply up to get equivalent fractions, or simplify, so divide out to get equivalent fractions. But the other thing we learned already is that you can check to make sure the cross products are true. And this can be really helpful, particularly if you are noticing that it's hard to simplify or it's hard to multiply up. So sometimes, our examples may not be as clear, but if you have to multiply by a decimal to get the right multiplier, right, it may be a little bit challenging. So what you can do is you can always check the cross products. So for instance, if I do 12 over 15 equals 4 over 5, I'm going to multiply both directions. So if I do 12 times 5, I get 60. And then if I do 15 times 4, I also get 60. So they are the same. And we can do the same thing here. So you can multiply 36 times 5 and 9 times 20, and you should get 180 in both cases. So sometimes this is the easier way, I think, to check to see if proportions are actually true. It tends to be much faster, particularly if you start getting more complicated fractions here, or if they're not as easy to simplify or to check that way, because sometimes they are challenging. Sometimes you think they may not be equivalent because you can't find the right multiplier or you can't find the right divisor, but they may be equivalent in fact. So this is probably the preferred way to check if your statement is actually true. So let's do one more example there. So now here's a harder one, right? So I have 4.1 over 7. I have 29 over 5. There's no way for me to get to from 7 to 5 easily by dividing. Like it's a mess, right? So I don't want to just say that these are definitely not true then. That's not the answer. The answer is that it's not going to be as easy. So let's use cross products instead to check. So your cross products are always going to be guaranteed to work to see if something is actually true. So let's go this way first. So I'm going to check 4.1 times 5. So I get 205, and don't forget I have one decimal place, so I'm only going to move in one decimal place here. So I get 20.5. And I'm going to check the other way too. So 2.9 times 7. Yes, okay. So here I have 63. Now I can already tell they're different. 14 plus 6 is 20. Again, I have one decimal place, so I have 20.3 here. So these are really close actually, but they're not the same. So because they are not equal, this is not a true proportion. Sorry about that, guys. But again, you don't just want to kind of give in because you can't find the multiplier or the divisor. Sometimes it's very difficult to find a multiplier or divisor to transfer from one fraction to the other because it could be a decimal or a fraction as well. So use your cross products to double check if your proportions are true. That's what I highly recommend. Okay, and we can even do the same thing. Let's do another harder one as well here with something like this. So is this a true proportion? And again, this is one that I don't even want to think about trying to find some sort of multiplier or simplifier to make these two fractions equal. I'm going to go ahead and use my cross products here. So I'm going to go this way first. So I have 1 and 1/6 times 4 and 1/2. I do have to change these over to improper fractions. Whether you want to do it beforehand or after you've cross multiplied is fine. So here I have 6 times 1 is 6 plus 1 is 7. So I have 7/6 times, and then 2 times 4 is 8 plus 1 is 9. So 9/2. Let's see, I'm going to do a little bit of simplifying first because this can both be divided by 3. So I have 7 times 3 is 21, and then 2 times 2 is 4. And then I'm going to go the other way too. So 10 and 1/2 times 1/2. Change this over. 2 times 10 is 20 plus 1 is 21. So I have 21/2 times 1/2. When I multiply straight across here, I get 21/4. And these are actually equal. So yes, a true, it's not a proportion wrong today, portion. All right, so sometimes we can't always just see by looking at them. For simpler ones, you may be able to, but for more complicated ones, definitely using that cross product check is the way you want to go. Now we're going to use this cross product idea, this cross multiplying idea in the next part of this video, which is on how to solve proportions. So what you're going to do, and again, there are different ways to solve proportions. So if you can, again, easily find equivalent fractions and things, then you're more than welcome to do that as well. We have techniques we've already seen for how to cancel fractions in other equations. So again, you can use other techniques we've already learned. But for proportions, they're very easy to solve if we use those cross products. So what you're going to do is you're going to do that cross multiplication first. So cross multiply, and then solve the resulting equation. So for example, 2 over 3 is equal to x over 30. Now, like I've said before, there is more than one way to do this. You may notice that 3 times 10 is 30. So 2 times 10 is 20 should be the answer. So if you can see that, then that's fine. But for most people, just cross multiplying or using those cross products is the easiest way to do this. So we multiply this way, and then we multiply this way. And you put an equal sign in the middle. So you have 2 times 30 is going to be 60 here. 3 times x is 3x. And now you just solve a regular equation. Divide both sides by 3. And like I said, that answer there is 20, which makes sense because this was an easy one where I could see that multiplier. 2 times 10 was going to be 20, and that's my answer. So if you don't like cross multiplying, that's okay. If you have another strategy that you've learned that works better, then that's fine. But cross multiplying tends to be an easy way to cancel out those fractions. But it only works for proportions. So just be careful if you have something else. So a little side note. Let's say you have an example like x plus 1/2 equal to 1/3, okay? We can't cross multiply here. Okay, so you can't just do like the 1/2 and the 1/3 because I had this extra x plus left over. So you can only cross multiply when have a fraction equals a fraction, or a ratio equals a ratio. So it has to be specifically ratio equals ratio, nothing else extra, no adding, no subtracting otherwise, like separately from the ratio. Okay, so you just want to be a little bit careful there. Let's do another example. So again, we're going to solve. (51/34) equals -3 over x. So it's a little bit harder how to go from 51 to 3. I'm not really as sure, so let's use our cross multiplying. So we're going to go this way, 51 times x, and then here, 34 times -3. So I have 102, or -102 here. And I'm just going to solve, divide both sides by 51, and we have -2. Now you can still check these. I'll let you check them at home. And you can check them just by plugging it back in. So if I plug in -2 here and I repeat that cross multiplication again, I should get a true statement. I should get that -102 equals -102. So you can still check your values by plugging them back into the original problem. All right, so here I have some complex fractions, but I have a fraction equals a fraction, or a ratio equals a ratio. So I can use that cross multiplying technique here. So I'm going to go this way, one side. So I have 1/2 times y. And then on the other side, I'm just using a different color here because this one's a little bit more complicated. I see I have 3/4 times 1/5. So I have 1/2 times y, so that's just 1/2 y. And then here I can multiply across, I have 3 over 20. Now you can go ahead and use your same regular fraction rules to solve. And you can do it a few different ways here. So if you want to cancel the fractions on both sides first, you can do that, multiply everything by 20. Or you may recognize that, well, I really just need to get the y by itself. So the way to cancel 1/2 is to multiply by 2 over 1. So there's a lot of solving techniques we've already learned, and you're welcome to use any one of those here. So normally I do like to cancel my fractions, but because I only have one y on the left here, I really just need to get rid of this 1/2. So the opposite of multiplying by 1/2 is to multiply by 2 over 1, and that will cancel it out. So I'm using that reciprocal there. So here I'm going to have 6 over 20, right, multiplying straight across. I do need to simplify. So I have y equals 3/10. So let's do another one. X over 4 equals 25 hundredths over 1 3/10. So again, we're just going to cross multiply here. So I have 1.3 times X. And then going this way, I have 4 times 0.25. So I have 1.3x, and then 4 times 0.25 is actually just the number 1. I have to just divide by 1.3 on both sides here. And I'm definitely going to take out my calculator at this point. Let's get it back up here. Where did it go? All right, so I'm going to just go ahead and type in 1 divided by 1.3. So I can see I have a really long answer here, so I'm just going to write a few of the values down. So 0.76923. And then I'm going to go and look at my problem, and you could do this on the homework or on an exam, is see how many places they want you to round to. So here we can go ahead and round this to about, let's say, 77 hundredths, maybe if we want to round to 2 decimal places. Now, the other thing you can do here is to get a more exact answer. So it just depends on how the question is asked. If it asks you to round, then we just use our calculator and it's pretty easy. But let's say they want an exact answer. How can I do that? Well, what we can do is keep it as a fraction, because fractions are more exact than the decimals typically. And we just have to cancel that decimal point out. So remember, we like to cancel by moving it to the right. So I'm going to move it to the right one spot, but I have to make the same change in the numerator. So if there's no decimal point, it's always on the right. And then I move that to the spot one, to the right 1 unit 2. So I have 10 over 13. And this also happens to be simplified. If I go back to my calculator and I type in 10 divided by 13, I get the same result. So I know that my answers match and I've done this correctly. So this is also a great answer here if you need an exact answer. So just make sure you read carefully for those questions and see how your final answer should be inputted. If you just need an approximation, then we can use our calculator. But if not, go back to that fraction form and clear out those decimals. And then that will be fine.